I'm an academic here in the Department of Electronics, and I'm also running this early stage spin-out called Adah. Adah is created to commercialize a medical technology. So you might wonder right off the bat what it's doing in a creative technologies fixture like this one. Well, in this case, the product that we're commercializing called StromoHab is intimately connected with creative technologies, not only in the sense of the technology that underpins it, but also in terms of the medical and the therapeutic element that the technology, that the system is aiming to apply. So what is it? Well, it's essentially a portable system that you wheel up to, for example, a treadmill in a physiotherapy clinic. And what it does, it provides real-time visual feedback for the patients who are learning how to walk again. And it also provides diagnostics. So the system is based on the concept that when the patient receives information about their activities in real time and is also able to interact with objects in the virtual environment, that they will develop new neural pathways by virtue of neuroplasticity and learn to do things better than they did before. So an example would be in stroke patients, for instance, that have lost a degree of proprioception, a degree of feedback coming from their legs or their hands from one side particularly. They will be able to use vision to fix those pathways just to an extent and to learn how to apply those movements more accurately. So the applications include stroke, which is the #1 cause of disability, and about a third of stroke patients require rehabilitation. Between a third and 2/3 of stroke patients require rehabilitation, and many of those would have problems with gait, with walking, and things of that nature. So that's a very big market. Other markets include Parkinson's disease, which is a disease that applies itself also in difficulty in mobility, kind of sort of shuffling movements and tremor and other types of applications. But there's a range of applications for this product that range from prosthetics, for example, replacing artificial limbs, to back pain and traumatic brain injury, sports injuries, and so on. So we're targeting 3 well-defined groups of customers. At the expertise high end, you will have consultants and specialist clinicians for example, in major hospitals, but also in smaller clinics who are interested in improving treatment efficacy, and also getting more patients through the system. And early support of just discharge is a big sort of objective of large health services. And the kind of technologies that we've put into StromoHab have been studied, have been researched quite extensively, and do promote these kind of this kind of improved throughput, and so on. At the sort of chalk face, you've got physiotherapy practitioners who are actually going to be handling the patients and treating them, and they would be getting real-time feedback in terms of diagnostics on what the patient is doing and how well they're doing. At the moment, in most cases, physiotherapists have to do quite a lot of guesswork, for lack of a better word. They don't often have a lot of quantitative information. What we're able to give them is very, very precise quantitative information on the movement and the improvements of the patient from session to session. You'll see more of that a bit later on. And finally, of course, at the money end, you've got department heads or service managers and so on who would like to see greater throughput, like to see beds cleared sooner, who would like to compare groups and compare different treatments and so on. In terms of the market, StromoHab sits kind of in the middling range. So at the bottom end of gait rehabilitation in particular, you've got sort of conventional treadmills. At the high end, you've got some of the systems, and I think a cave was mentioned here before, so a cave system, a large room-sized virtual reality environment that you can, I suppose, in principle, bring patients into. And there are a small number of these type of systems that are used for rehabilitation of patients around the world. They tend to cost you know, $1 million or maybe a little bit less than that, depending on how much they have. They'll also have a full sort of range of motion capture cameras and require an engineer to operate them. So this is a very high-end sort of system. So the science underneath this is that, first of all, that human locomotion is an adaptive process. This is something that we worked on some years ago. And that means that it's a learning system, basically. It means it can be improved, it could be adjusted and made better, made worse as well, but it can be improved in the case of pathologies. That virtual reality feedback, biofeedback that you get from systems like this operate via what are known as mirror neurons or other kinds of systems that in the brain that are able to apply neuroplasticity, are able to kind of repair the pathways as I described previously. That performance and gait assessment are important means of assessing how well a patient progresses. Yeah, so obviously if the physiotherapist knows that the patient is doing better today or doing worse today, then it allows them to put numbers on that and then to define a new therapy regime associated with that. But also importantly, on the sort of the more creative side, when patients are able to see something on the screen, they're able to see their own performance, they're able to see an environment that they can engage in, it improves their enjoyment or their engagement, their sort of sense of taking part in the activity. And what that does is it tends to make them want to come back. So it improves compliance, and by improving compliance, it improves the treatment. So all the studies state that this is an important factor of virtual reality treatments, generally speaking. So it's important to put something on the screen that the patient is going to want to watch. And that's relatively easy because at the moment they watch nothing. They just walk on a treadmill, for instance. Yeah. So what do we put on the screen? Well, we can put a lot of different kinds of environments. We're in the prototype stage of this system, so we don't have many to choose from, but these are sort of mock-ups of some environments that you might be able to show the patient. So you can walk in the woods, you can walk on a boardwalk, you can walk in a busy scene or in the country and so on. And what we're able to do is track your movements. We show you stuff, we show you interesting stuff on the screen. We track your movement, but we also put an avatar of yourself in the environment. So by virtue of the motion capture that we apply, we can put a full body avatar of yourself walking in the environment. You see yourself from behind typically doing different tasks in the environment. So you could be interacting with the environment or you could be just walking. So I'm just going to conclude by showing you a little video. This is a prototype, a lab prototype that will demonstrate what the technology can do. So what to notice here is that you have a big screen. You have a patient, a student in my case, walking on a treadmill. You will see some kind of environment on the screen. They will see some kind of environment. But importantly, you'll also see a diagnostic screen. The diagnostic screen contains gait parameters. So it contains lots of information on what the body is doing. We have access, by virtue of using the Microsoft Kinect, to a whole host of different parameters of the movement. We modeled the skeleton, we've got joint angles and so on, but the input we're getting from clinicians, they don't want all that. They just want something very simple. But nevertheless, the simple stuff that they get is much more than they have now. So it enables, for instance, to compare between session and session, or if a physiotherapist changes from one day to the next physiotherapist will be able to see what the performance was the day before. Yeah. So it's a very short clip, and as I say, it was done in the lab. And I'll conclude after I show it to you.
This is the Stromo Hub system. This can be wheeled up to the front of any treadmill, and then a tablet computer or other as the control interface. Today this laptop will play the role of our tablet computer. If you'd like to give us a wave with your left arm, a little bit. There we go. And a clinician name. And he's going to press the go button. And we get taken to the main user interface. We can see that this is a new patient, so there are no existing tests. And then if you would just like to get Dan started on the treadmill. and Joel's going to click the button in the bottom left which says Start New Test, and we can see that the steps that Dan's taking begin to come in. We can see his average speed calculated there, approximately 1 mile an hour, which is what we've got the treadmill set at. We can see the step count increasing as he takes steps. Notice that when Dan slightly twists his shoulders from left to right, the camera pans. It really gives a sense that you're connected to the environment.
Okay. Okay, so all of that, it's important to add, all of that is in the bit that you're wheeling up to the treadmill. So we don't need to connect up by RS-232 USB or anything like that to the treadmill. Treadmill is a passive thing that's run by the physiotherapist separately, but we pick up the speed, we pick up everything from the patient's movement. So that sort of illustrates the kind of the level of technology that we've managed to do so far. Where are we now? Well, we've got clinical trials in preparation. We're just going through the ethics approval process at Addenbrooke's Hospital in Cambridge. We have an angel investor who's been supporting us as we move forward. We're looking for additional investment. We're also looking for some input as in the form of a chief executive officer or someone to drive the business commercially, because there's only so much I can do on the academic side. But also, I'd be interested to hear about any possible technology partnerships. I mean, one thing I'd like to really do is make the experiences very engaging for the patients, because I think that's quite important from the therapeutic standpoint.